All right, this is 5-4 equilateral and isosceles triangles. The essential question that you should be able to answer at the end of this lesson is, what conjectures can you make about the side lengths and angle measures of an isosceles triangle? We're going to define what we call legs, vertex angle, base, and base angles. We're going to talk about what those are, and you're going to learn how to use those base angles in a theorem, and you're also going to learn how to use isosceles and equilateral triangles to solve problems. Alright, so we're going to start talking about equilateral and isosceles triangles. First, we got to define a few things. We're going to start by defining what's called the base of a triangle, and the way this is kind of oriented and switched. This is the base, right? And then this top angle, that's going to be called the vertex. Okay. And whenever you have at least two sides of a triangle that are congruent, we're going to call these the legs. All right. So I have my vertex angle, my base side, my two legs, because those are the two that are congruent. And then we're going to call these two things right here, this one and that one, those are called my base angles. So that's a base angle, and this is a base angle. Alright, so we're going to need to know these different pieces so that we can use them and talk about different parts of the triangle and solve some problems. Alright, so we're going to start with what's called the base angle theorem, and that simply says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically, if you want to kind of think of it as a conditional statement, and that just says if AB, segment AB, is congruent to segment AC, then what you can say, then what you know, because of that, is that you know that angle B is congruent to angle C. Right? So if you know these two sides are congruent, then that means that this angle B has to be congruent to that base angle C. Right, now what we have is what's called the converse of the base angles theorem, and that just simply means we're going backwards. So I'm told that angle B is congruent to angle C, which then means that if I know these two base angles are congruent, then that means that these sides here, AB, is congruent to BC. So again, as a conditional statement, if I'm kind of shortening this down, if I know angle B is congruent to angle C, then my conclusion then is going to be that segment AB has to be congruent to segment AC. Example 1, we're going to start off real simple. I have a triangle DEF, and I'm told that segment DE is congruent to segment DF, and I want to name two congruent angles. Well, it's kind of tilted, but these are my two sides that are congruent, so that makes these two, angle E and angle F, my base angles. And so if I know the two sides, DE is congruent to DF, then I know then my angle F has to be congruent to angle E. And that's all there is to it. That's just a simple basic problem. Alright, we have now what are called corollaries, or kind of an afterthought or a consequence of the base angle theorem. They lead from the base angle theorem. And it says if I know a triangle is equilateral, then it's also equiangular. And then the opposite of that is true if I switch the hypothesis and conclusion. If a triangle is equiangular, then I know it's equilateral. So I can kind of use these two interchangeably. If it's equilateral, it's equiangular. Or if I'm given that it's equiangular, then I know it's equilateral. Example 2, simply given, find the measures of angle P, Q, and R. And looking at the picture here, I noticed that all three sides, all three legs are congruent. So that tells me that it's an equilateral triangle, which means it's also equiangular. So I know all three of these angles have to be the same measurement. And to solve it, to actually find out what those measurements are, since I don't know anything else about the angles, I'm just going to call these an X. So if this one's X, that has X degrees, that has X degrees. So I simply know, adding them up, when I have x plus x plus x, has to be 180, because that's all three angles inside a triangle add up to 180. Since they all happen to be the same, that means I have 3 x's. And if I divide by 3 on both sides, I get that x represents 60, which happens to be 60 degrees. So I know the measure of angle P is equal to the measure of angle Q, which is equal to the measure of angle R. And I know all of those have to equal 60 degrees. Example 3 says find the values of x and y in the diagram. So here's the diagram. We've got to look at it and kind of see what we can, what conclusions we can make from that. Real quickly, looking at this triangle right here, KLN, I noticed that all three of these angles are the same. So by that corollary that we were just looking at, if all the angles are the same, that means all the sides are the same. So I would know that this side is equal to that side, which is equal to that side. And since KL, segment KL is 4, that tells me that y has to be 4. Okay, easy enough. And then I look at this other part. I know that this angle right here, LNM, is congruent to angle LMN. Okay, which means I have 2 base angles that are congruent. So that means this side LN has to be congruent to LM. So I could draw a tick mark there. And so if this side's 4, that means this side's 4, which is this side, LM, has a length of 4, but I have an x right there, so we're going to do x plus 1. I know that has to equal 4, and then if I just simply subtract 1 to that, that gives me x is 3. Okay, so my answer is y equals 4 and x equals 3.